Welcome to another lesson on All About AI. In this lesson, we are going to cover what is machine learning, what are different types of machine learning. We'll cover what is supervised learning, what is unsupervised learning, what is reinforcement learning. Now, first thing is how we train the machine. So when we are talking about training and learning process, machine learns very similar to the way we human learn. We see some example and then we can understand the pattern and type, and based on those example we can detect, okay, this is X, this is Y. Very similarly, most of the times we'll be training machines or the programs or algorithms with a lot of examples. We'll feed a lot of data. Say we have few pictures of cat and dog. All the pictures are categorized or labeled with their respective type. Then we will be feeding this to machine learning algorithm. There are various types of algorithm. We'll go why we have different types of algorithm at later stage. But at this stage you can think like we have algorithm and we are feeding data to train the algorithm. So here, like, we have trained the algorithm with 5 examples for dogs and cats. So with this, the algorithm is trained. Once this is trained, we have a trained machine learning model. Now when we give another new picture, say it's a cat picture, then this trained model will get the input data and it will give the output as cat. Maybe another example could be a dog example, and again similarly algorithm will give us. This is how most of the machine learning model, though they are very similar to the way we human learn, there's a difference. For machine, everything is number. When we are training algorithm, actually we are converting these pictures into its equivalent number format. Say pixels are converted into equivalent numbers for each area in this pixel, and that is being fed to algorithm. Algorithm cannot see anything. Based on this number, it finds pattern, and when after training, during testing time, we send new photo, it can recognize based on that learned pattern. And now there are 3 different types of machine learning algorithm. First one is supervised learning. Next we have unsupervised learning, and the third one is called reinforcement learning. Now in case of supervised learning, as it talks about supervised, so basically we have some labeled data through which the model is being trained. So like in our example, we have label for all this data and machine is getting trained using this label data. So we have data and at the same time we have a label which is telling, okay, this data relate to this level. And that's how machine is trying to train itself. It's trying to learn from this information. Since somebody is telling, somebody is supervising the learning algorithm, we call these types of machine learning algorithm as supervised learning. Another example could be, say we have many houses in different places and we would want to train the model. Suppose we have few variables like location, area and feet, bedrooms, floor, the color of the house, and then we have price in dollars. So you can see here algorithm is getting the data along with its level. So here price is the level and we are going to train the model using this data. So once we have this trained model, we feed a data or we ask a question, what would be the predicted price for a house which is located in Tampines, area is 1600, bedroom 3, floor 2, color blue. The machine learning algorithm will take this as input and it will predict that okay, the price is 1.52. Now there is a difference between two categories of model that we have shown here. One is trying to do classification. So that's why supervised learning has two categories. One is classification. In classification, based on data, we are predicting the test data, which class it belongs to. Suppose we have two class, cat and dog, and it may be classifying the data as cat. So it's a finite number of classification that is done through this supervised learning method. Other category of supervised learning is called regression. So regression is the second example that we went through, the housing price. Now the price is a continuous variable. In this case, price could be from 0 to say up to 3 million. Any number is possible between that based on location or combination of various data elements. So when we have continuous data as output, we call it regression. When we have fixed number of classes as output, we call classification. So suppose we are trying to detect a transaction, whether it's a fraudulent or not, the output could be either yes or no. So in that case, it's a classification problem. Another thing could be we want to predict the price of stock. The stock prices could be a continuous number. So in that case, we will be using a regression problem to be solved. So classification, classifying the data in different categories, and in regression we are getting a number which could be a continuous number. Now let's take a quick look at some of the examples of supervised learning from our day-to-day life. I think all of you have used spam filtering, which uses different keywords and past behavior to detect if email is spam or not spam. It's using classification algorithm. Similarly, other kind of classification algorithm usage are like image recognition, sentiment analysis, loan approval prediction, customer churn prediction. In customer churn prediction, algorithm identifies customers those are at risk of cancelling their service based on various behavior patterns. Another very well-known classification is fraud detection. So like identifying fraudulent transaction on credit cards or bank accounts based on transaction or spending pattern. Let's take a quick look at two regression examples. One is stock market prediction, where algorithm forecasts future stock prices based on historical data and market trends. Weather prediction, this is another area of regression algorithm usage, where forecasts of future weather conditions are made based on historical data and different atmospheric measurements. Unsupervised learning. So we have seen in case of supervised learning we have a level, but in case of unsupervised learning there is no level. We have a lot of data, but there is no level associated with this data. The purpose of unsupervised learning is to find pattern in the data. We don't know upfront what is hidden inside the data, but once we are using unsupervised learning algorithms, we'll use the data to come up with pattern or cluster, or it can see some grouping of data. Say again, we feed a lot of data into unsupervised learning model. Model will train, and after that it will give, say in this case, two categories. one is living thing and one is non-living thing. We asked model to analyze the data and can you give us two different groups of information from this data. And that's how this model came up with, by linking the pattern between living things and non-living things, and that's how it's grouped them in two categories. We could have asked different question. Can we divide it into 4 categories or maybe 3 categories, or is there a complete difference in all this data compared to whatever we have seen? The model can also try to distinguish, say, based on color. Maybe all the green colors will be combined together. Whichever picture has a more green, it may combine together. Whichever is white, it may combine together. Purpose of unsupervised learning is to come up with pattern or differences between different data elements. Now we'll quickly take a look at unsupervised learning, a different usage. Customer segmentation. Unsupervised learning is used for segmenting customers based on their buying habits. We can group them for basket analysis, targeted promotion, finding hidden trends. Algorithm analyze stock market data to identify unlabeled patterns, potentially revealing hidden investment opportunities. Another area of usage is image segmentation. In medical imaging, this learning method is used to group pixels in medical scans like X-rays or MRIs or CT scans, helping doctors and radiologists to identify bones or tissues for further analysis. Another usage is document clustering. Areas like research, unsupervised learning algorithms are used to group research papers based on keywords, helping researchers navigate large collection of scientific literature and focus on particular area of their interest. Anomaly detection is another area where unsupervised learning is heavily used. Cybersecurity or network traffic analysis identifies unusual pattern that deviates from normal user behavior, potentially indicating a cyber attack or some kind of vulnerability. Another usage is content recommendation. I am sure you all have used some kind of streaming service like Netflix. They use unsupervised learning to analyze user viewing habits and then suggest similar movies or shows, personalizing the streaming experience. Reinforcement learning. Reinforcement learning is another prominent category of machine learning. This learning focuses on feedback and experience. In this case, models are trained based on feedback loop and experience. There is no supervisor, rather it learns from its trial and error method. Closest analogy would be the way human learns riding bicycle. Maybe when you start learning bicycle, it will be a bumpy ride. Sometimes you will fall down. It may give us challenges when we start learning it, but over the period of time, we will learn how to move our pedal, how to move our handles, how to sit properly, how to tilt your body. So every time we face some challenge, we know that okay, this is not something we should repeat. We should try something differently. After a period of time, we'll be comfortable with bicycle and we can run it or we can ride it smoothly. Exactly same thing happens in case of reinforcement learning. Model learns from its interaction with the environment, and after a lot of training, it learns what is the optimal behavior. So reinforcement learning is the branch of machine learning where an agent learns to make decisions by interacting with an environment to maximize some notion of cumulative rewards. Now, to explain this, I'll use an example of a grid or maze, as you can see in the screen. It's a simple grid. Before I go to explain how it works, first you need to understand few vocabulary about reinforcement learning. Here I'll go through few key components of reinforcement learning. These components are key to understand, and also these are important in terms of designing to facilitate this reinforcement learning process. First, I'll talk about agent. The agent is the learner or decision maker. It is the entity that takes action to achieve a goal or objective. So in this maze, you see the robot, you can think it as the agent. So in different contexts, agent could be a program, agent could be a robot, or agent could be something that is interacting with environment and the one that is making the decision. Next, I'll talk about environment. The environment is everything the agent interacts with. Environment responds to the agent's action and provide feedback in the form of states and rewards. So in this grid world, you can think the environment is the entire grid with all this setup and all these rewards, everything together. It is the environment for that agent. Now let's talk about state. A state is a specific situation or configuration of the environment at a given time. It represents all the information that agent needs to make decisions. So state is more from an agent point of view. Whatever it can see, whatever it can interact with, whatever it can understand, and it's about a specific situation or configuration. So in this case, in this maze, you can see there are total 9 states. So every step, agent will move from one state to another state. Similarly, if you are thinking about a strategy game or something, every movement or every action can result into another state. Next thing is action. Actions are the choices available to the agent at each state. Actions are what the agent does to influence the environment. So this is the main interaction with environment, and that's how agent knows what rewards it gets from the environment. Next we'll talk about reward, which is the key concept behind reinforcement learning. We don't have any level in reinforcement learning, but we have a concept of reward. A reward is a signal from the environment to the agent indicating the value the last action taken. So rewards reinforce the agent to take good action and not to focus on bad action. So it's basically driving the agent toward good behavior. Policy. The policy is the agent's strategy for deciding which action to take in each state. It can be a simple set of rules or it can be a complex decision making system. So ultimately, the objective of reinforcement learning is to learn the optimal policy, because policy will tell in each state which is the optimal action that agent should take to maximize its rewards or its cumulative rewards. There are few other important vocabulary like value function, Q function or action value function, exploration, exploitation, transition probability, etc. But at this stage, this is enough to understand how reinforcement learning works. Now we will take a look at general setup of reinforcement learning and how the actual training process works. We will again refer the grid world for reference to better understand and link all the components. So we have an environment, which is the grid world. We have an agent. Agent starts interacting with environment by referring the policy. So if you think that initial state is at start S1, this is the state where agent starts interacting with environment. Initially, we might have a random policy or some previous policy that we may refer, and agent will take action based on that policy. Now once the action is taken, environment will return the next state, and also it will give a signal or reward back to agent. So if you can think of from this maze perspective, agent could be in S1 after it takes an action which is like moving either up, down, left, right. In this case might be it has moved from S1 to S4, which is a right movement, and because of its movement it will obtain a reward -1. So this is a generalized structure for any kind of reinforcement learning, where agent will interact with the environment, it will behave based on its policy and act. Environment will return state and rewards. Once environment returns reward and state, algorithm will update the policy based on the state and action taken. This loop will continue till the end of this game. Then this process will be repeated again and again, and previous experience or previous stored information will be used to optimize the policy. Once we have a optimized policy, we will know training is complete, and then agent can behave the optimal way. Similarly, other kind of reinforcement learning training methods, say you want to train the agent to optimize a movement or finding the shortest path, all kind of scenario, this basic structure will work. There could be different algorithms, but this structure is applicable to all of them, and that's how the reinforcement learning algorithm learns. We have a 3x3 grid. It is an environment with total 9 states. Here you can see numbered by S1, S2 up to S9. Here the agent can take 4 action in each of the. So it will start moving. Suppose it moves in this direction and then it goes there. Then this game will end here. We call this one episode, and in this episode agent obtained rewards -1 plus -1 plus -1 plus -10, which is -13. Now again another episode will start from here. Maybe agent will go this side, and then it remembers the last time it went up, so it's not in right way, so it again will start moving from this side, and suppose it again goes here and it tries here. Maybe it will move in various direction and somehow it will reach here. So this one episode, and again we will be accumulating values for the overall start to end, and from each state what is the value. So suppose it was in S6, and if it moved from S6 to S9, then the value from S6 would be -1 plus 10, which is +9. So that way every state will have a value and corresponding action. So it took an action from S6, move right, and it got a value of 10. So we'll have a mapping between this state and action reward that it accumulates. This way we'll be running this multiple times. Agent will try in many of this grid, and ultimately it will come up with the optimal action. In this state will be to move up. If it is in S2, the optimal action will be the from S2 would be to again move up. S3 will be moved right, S6 will be moved right, and then it reaches the S9. Similarly, if it is in S7 state, the optimal action will be to move left. It cannot move right, it cannot move down, and moving up is also something it will learn that here it is getting negative points, so it should not do this again. So optimal action in S7 will be move left, S4 will be move left. So that's how we will be concluding about reinforcement learning. Agent will get trained, it will learn from its experience, and finally it will come up with the optimal learning is to find the optimal policy or maximize the reward over a period of time. Reinforcement learning is very important in machine learning, and predominantly it's used for all uncertain environment or anything where the strategy related learning is required.